we left off right here, and I wanted to remind you of why this isn't going to work. Just real quick. The reason this has no answer is because you want something that you could raise to the fourth power, right? Because it's 1/4. So if most students, when they see it, they're like, oh, it's got to be -3, right? But -3 to the fourth, because it's even, really means -3 times itself 4 times, which is never going to work because that's an even number, which means it's positive, right? Positive, not negative. That's going to be problematic for you because, what is it, K? I think, N. N equals 4 is even, okay? That's why he says, the author, if N is even, like it is right here, 1/4, 4 is even, and B is negative, like it is right here, -81, then B to the 1 over N is not real. It's not going to exist. Now, I know what you're thinking. You're thinking, Alana, E looked the same. But E isn't the same because the only thing being raised to the fourth power in E is just the 81 because there's no parentheses. All right, now let's move on to the next thing. Let's simplify some, shall we? All right, so we want it 64 to the -1/2. Ooh, tricky. They gave us a negative on top of everything else. Okay, so let's see here. See? Right? Isn't that what that is? Now remember, negative powers still will do what they did in the last section. You're going to have to go 1 over 64 to the 1/2. You move it down and lose the negative. Right? That little negative right there has got to go. So you move it to the denominator. Okay, but 64 to the 1/2 is really the square root of 64. Again, usually we don't even bother with the 2, but I'm just putting them in there for you, for your notes, so you can keep it clear. And the square root of 64 is 8, right? Remember, the square roots are along the diagonal of your times table. So if you know your times table, you know your square roots because they are the diagonals of a times table. Poof, I just brought up a times table so you could see. So see 64 right there? So what row or column is it in? 8. See, that's why. They even have on this table the perfect squares highlighted. That's what those numbers are called. They're called perfect squares. And then the number they correspond to is called the square root. So 81 is a perfect square. The square root of 81 is 9. All right, so now let's look at the next one. We've got -64 to the -1/3. Now you might be thinking, uh-oh, we're in trouble because there's some negatives floating around, but we'll be okay. It has to do with the fact that this was an odd power. See how it's a third? That'll be all right. So -64 to the -1/3 is equal to 1 over parentheses -64 to the 1/3. See, the only thing that moved was everything moved to a denominator, but you lose the negative power right here. You didn't lose the negative in the parentheses, because he's not a power. He's just the number -64. All right, so now this is equal to 1 over, what you're finding is the third root of -64. So you need to think, okay, what times itself 3 times would get me -64? Now I happen to know just off the top of my head that that's 4. But how could you get it if you don't? Well, 1, you should try to learn your numbers a little bit, but 2, you could always use your calculator to help you out. Okay, so let me quit, because that one was an error. And let me do negative, oh, here. It's a third root, right? So if I go math number 4, third root -64, enter. There you go. Or you could do parentheses. You could, because maybe you didn't feel like converting to the root thing. Parentheses -64, close parentheses, to the 1 parentheses third. There you go. And again, remember that power should be in parentheses for most of you. It's just there's no point for my calculator. All right, so I gave it -4. That's where that denominator came from, but then it was still underneath 1. So negative 1/4 is the answer. All right, what about C? Well, C, you might be thinking you're in trouble because you've got that negative negative combo again. But let's be careful. Negative 64 to the negative 1/6. Now the trick here is that that negative is not inside the parentheses like it is in C and B. In B, it's in that parentheses, which makes things harder, and D as well. But because it's not in there, this is really just a fast way of writing this. And as a matter of fact, I'm going to make that written like that, just so you can see. There we go. All right. Again, because that negative 1 is not in parentheses, that negative right there is not in parentheses, it's really negative 1 times this stuff. So the negative power right here with that fraction is going to cause it to go into the denominator, but only the part that that negative power affects. So you're going to have to put 64 to the 1/6 down here, but the negative 1 is still sitting on the top. Now 64 to the 1/6, again, ick. So let's make our calculators do it. So you could do parentheses 64. Actually, I don't even think you need parentheses on my calculator. 64 to the parentheses 1/6. Just to get you guys used to it. It's 2. Now, if you didn't want to do it that way, you could also do 6 math number 5, which is the xth root. So it takes the number you just typed and makes it the root. And then you say 64. Okay, so one way or another, you still get that it's negative 1/2, which is, we also know, negative 1/2. Again, I don't really care about whether you put the negative out in front or if you want to write it in the numerator. Those are both correct to me. Oh, I just closed my calculator. Hold on. All right. In other words, I'm willing to accept both. Me personally, I will accept both of those answers. So same with this, actually. I mean, you learned hopefully somewhere in pre-algebra that with a fraction and a negative, it doesn't really matter where your negative is as long as you have one. So you can have it in the top, you can have it out in front, you can have it on the bottom. It's all good for me. Okay, so last one. Negative 64 to the negative 1/2. So parentheses, negative 64 to the negative 1/2. Okay, so in this case, because that negative is in the parentheses, it's all going to go down. So you write negative 64 to the 1/2. Now, when you shift things like that, the only thing that gets gotten rid of is the negative power. The negative 64 is inside the parentheses. That's just a timesing by negative 1. But the negative in front of that half has to move and be gotten rid of. Okay, so what number times itself must be 64? Now, most students think negative 8. But you wouldn't be correct because negative 8 times negative 8 is positive 64. See the problem? So what's going to happen here? So you'd say, oh, I want parentheses, negative 64, close parentheses to the 1/2. Put it in parentheses if you don't have my calculator. Oh, look at that. It's not real. Because you can't take the square root. I mean, think of what you're doing. You're trying to take the square root of negative 64. That's not possible. Not in the real number system. No real solution. There is an answer, but it involves the letter I. If you've ever seen, it's 8I with a little 8I, like that. Usually italicized, but you know, hey. Right? They usually write it like that. So we will deal with that a little bit in chapter 7, but only a little bit. Now let's look at this definition. This is of a rational exponent. So for the counting numbers p and q, remember counting numbers are 1, 2, 3, 4, 5, 6, 7, 8 forever. And q is not 1 and b is any real number at all. You can make it decimals, fractions, whatever. Then for which b to the 1/q is a real number. In other words, none of this whole non-real solution thing. Okay? So if that's the case, then b to the p over q can be written one of two ways. Let me write them both. You could write it as b to the p to the 1 over, oopsie, to the 1 over q, like that. I'm breaking it up. I'm saying, look, it's p over q. This is what it was written as, right? So if it's p over q, what you can do is break up the numerator and the denominator there. So put the numerator, because it's really p over 1. So I put p right here, b to the p over 1, times 1 over q. Or I could do it vice versa. I could say, oh, that's also b to the 1 over q to the p, like that. That would also work. I better underline. And no, there's no way to make that giant gap at the bottom of that parentheses. I don't think I can make that go away. So sorry, we're stuck with that. All right, now what if it was negative? Well, it's the same idea. It's just that you do 1 over. So you'd say, okay, well, that's 1 over b to the p to the, let's see, fraction 1 over q. Or it's equal to 1 over b to the 1 over q to the p. Those are the ways to think about it. Okay, so you either do the 1 over q part first, that's these back ones, or you do the 1 over q part first, or you do the p part first and then take the 1 over q. Honestly, most of the time we do the back one because this tends to make numbers smaller first. So I tend to do the second one. Same here, I tend to do the second one more often. Not that the other way is wrong, it's just a little bit harder that way. So let me give you some examples of what I'm talking about here. So, because I think with B's and P's, it's all confusing. So what if I had, let me think, 4 to the, good grief, 4 to the 3 over 2. What I'm telling you with this is that you can break this up two ways. You can make it, I'm going to show you both. I could say, hey, that's 4 to the 3 to the 1 over 2. That's that first one, b to the p to the 1 over q, which we know is, hold on, 64 to the 1 over 2, which we all know is 8, because that's the square root here. Square root of 64, which is 8. Okay, that's one way you could go. Or I could write it one other way. That's the second way that I'm trying to show you. I could say 4 to the 3 over 2 is equal to 4 to the 1/2 to the 3. Okay, which is now 4 to the half is the square root of 4. And you're raising it to the third power, which is 2 to the third, which is 8. Right? So either way you get 8, it's just a question of, do you take the power first or do you take the square root part first? Right? But you get the same answer either way. Good? I wanted to throw in another example here. What if I did 8 to the negative 2/3? Well, that's 1 over 8 to the 2/3, which is 1 over, and you could run it two ways. You could say, this is the second line, you could say 8 to the 2 to the 1/3, which is 1 over 64 to the 1/3, which is 1 over 4. Or I could reverse it and do the third part first. So 8 to the 1/3 to the 2, and that makes 2 to the 2, which makes 4. So either way, you still get a fourth. And that's what that second batch was saying. So this example over here is of the first one. This example over here is of that second one.